Well, thanks for everyone sticking around. I wanted to give another round of applause to all of our classmates presenting today. They did a great job. Let's give it up for everyone. It was really cool to see what everyone did this year. Now we're going to go into our project a little bit about the optimization of plant support center locations and data storage systems. I'm Bowman Raskin. I graduated from Virginia Tech last year with a degree in finance and sports media and analytics.
My name is Nathan Lowry. I earned a degree in aerospace engineering here from Virginia Tech.
My name is Andrew Malta. I graduated with a degree from here with business information technology.
And my name is Mona Schiller, and I most recently graduated with a master's in mechanical engineering this spring.
So first, we wanted to just meet our sponsor a little bit. We know they're not in the room right now, but we had a big team helping us throughout the semester for the full year. And our faculty advisor from Virginia Tech was Dr. David Teagarden from Accounting and Information Systems, and he is an associate professor. And I'm going to pass it over to Nate for our company background.
Thank you very much, Bowman. So in case you didn't know, X Energy is a nuclear engineering company that designs small-scale nuclear reactors and the fuel to power them. So they're Generation 4 high-temperature gas-cooled nuclear reactors. You can see their flagship design right there on the right. That's the XE100, and then that little steel-looking ball is actually the fuel that powers those reactors. So the key problem that they're facing is that they want to design a plant support center network that will centralize the monitoring and diagnostics of these reactors. But they're still currently in the design phase for their reactors, so they haven't finalized what sensors are going to be on the reactors and how many of them there are going to be, which means they don't have a full set of information on how much data these reactors are outputting, and therefore how much data are they going to need to store. And there's also some questions over geofencing laws. So like what nuclear data can they send across state or even international lines and keep in compliance with different government agencies. So our key question is, how can energy collect, store, and transfer data in a safe and legal manner between nuclear power plants and plant support centers to optimize system management and maintenance efforts? So our key problem was broken down into two main parts: the plant support center problem, which is focusing mainly on site selection. So where in the United States makes the most sense for X Energy to place a plant support center based on a number of factors. So there's like environmental stability, like societal stability. So like if something bad does happen in that area, how fast is that county or city able to recover from that? Real estate values, data latency. So how quickly can information be transferred from one location to the other? Inventory tax rates, and then also opportunity zones, which can provide X Energy with a tax break. The other problem is the data storage problem. So what data do they need to store based on government regulations and for how long? And then also, what do they want to store on site in a readily accessible hot storage? And what can be stored off site at the data center, which is more compressed than cold storage? And then also, what is their total required storage capacity? So like how much are they going to store for a reactor for out its lifetime? So we had three main deliverables. The first is a site selection dashboard that was built in Tableau. Features several views looking at the state and county level, and also things like inventory taxes. It's very interactive and allows the user to specify what variables are more important to them when considering their site selection. We also have an Excel spreadsheet that's VBA enabled that allows users to input their sensors and a variety of data points about those sensors that will output storage requirement needs over time. And then we also had a comprehensive report that does include user manuals detailing everything we did in preparing the data and then creating our other deliverables. So I'm going to pass it off to Boom to talk about our analysis methodology.
Thanks, Nate. Now we're going to talk about our analysis methodology for the plant support center problem. We were tasked with this problem. We knew we needed to collect some data. So we talked a lot with our sponsor about what some of these main things they wanted to look at were. And first we came up with this climate resilience and screening index value, which is a value about high or extreme weather conditions and the ability that a county has to recover from one of these cases. And next was real estate values. So this data is from Q3 2022 median home values. After this, we collected data latency rate values, which is basically the number of high speed connections in a certain county. We also collected data throughout the country on opportunity zones, which Nate mentioned is basically a capital gains deferral or tax break if you go have a building in one of these locations. And finally, we have inventory tax rates at the state level, just when X Energy decides to put warehouses in these plant support centers so that they can try and save more money. Using all of this information, we created a multi-criteria decision analysis and created a location rating value based on the first three variables, as you can see on the screen. And you can see they all have specific ratings depending on what the sponsor wants to rate more than others. Using everything, we created our plant support center Tableau dashboard. And the purpose of this dashboard is to find the most optimal location to place one of these plant support centers. I'm going to pass it over to Andrew to detail some more about the plant support center process.
Thank you, Bowman. So what you see before your eyes is the beautiful dashboard we created. So Bowman gave you guys a rundown of the multi-criteria decision analysis matrix we created and the formula behind that. So what X Energy will be able to do is move these sliders left and right, depending on if they value real estate more, data rates more, and those will update the map. So if you push up real estate to 100%, it's going to turn New York City and LA County just bright red, unfortunately. And what you can also do is filter. So once you create all these counties, if you're on the state view, you're able to bump it down. So say you only see the top 10 states, you can do that. It's not really there for counties because there's a lot of counties. And also, if you only wanted to see counties in Florida, so say you look at the state view first and you do not like California or Washington, or you do like California or Washington, you can only select California or Washington. Now we'll just remove every other state that's not California or Washington. As well, we have an opportunity zone slider here. So as Bowman talked about, if you want a lot of opportunity zones, say X Energy wants a lot more flexibility before they want to put these plant support centers, they can increase the opportunity zones to say 10. So they can only show counties with 10 opportunity zones. And here at the bottom, they have each opportunity zone. So when you click on it, it will take you to a website and we'll show you the tax breaks to get there, its location within the county, and things of that nature. And then here at the bottom, that little search bar, you can actually type in an address and it will pull you into the exact opportunities that it's in. So say you already have a location picked out in the county and you want to see if you can get extra tax breaks on it, you just put your address in there and it'll tell you. Yeah. So using this map, we're able to give X Energy the recommended county list. And the first thing we did was we inputted the CRSI and real estate values at 80% and the data latency at 40% because they valued the data latency a little less than real estate and CRSI, which refer to sustainability. So that was the first step in the process of selecting the counties. So once we're able to do that, and we change the map, we can quickly see which counties are good, which counties are bad. And then once we saw our counties that are good, you can click on them, and they will all produce opportunity zone lists. And then once those opportunity zone lists are provided, you can go through each of the lists and see where the PSC can be located. And I'm going to pass it off to Gwen, and we'll talk about the data storage problem.
So yeah, as Nate mentioned earlier, we had two problems. There was the plant support center problem as well as the data storage problem. So going into the context of this problem, here you can see one of their nuclear reactors, and on these reactors, they have a number of sensors on the orders of hundreds and thousands. And so with each of these sensors, they have a specific sensor types that can be pressure, temperature, radiation, etc. And so we assigned each of these sensors a certain sensor type, and with each sensor type, we did associated parameters. And so we chose parameters of data packet size. So when you pull data from the sensor, how big is that data packet? Storage frequency. So not only how often are you pulling data from this sensor, but how often are you storing that data? Hot storage retention. As Nate mentioned earlier, hot storage is that easily accessible data storage. So typically on site. Quantity, so how many sensors are of this sensor type, hot storage and cold storage compression. So when you put it into that data storage method, how much is that data being compressed using their compression methods? And so with these different sensor types and their associated parameters, we are able to put this into a VBA for Visual Basic for applications enabled spreadsheet. And so here you can just see one sheet of our spreadsheet. We can't show you everything in this presentation, but on this first sheet, users can input a number of sensors here on the left in that yellow section, and they can add this to an already existing list of sensors if they've already used the spreadsheet, or they can replace all the sensors that are already existing. And so then in another sheet in the spreadsheet, they can then vary those parameters I was talking about before for each of these sensor types. And so using this VBA-enabled spreadsheet tool, we're able to show the hot data storage capacity needed for the nuclear reactor over time, as well as the cold data storage over time here on the right. And so something important to note is that for their hot data storage, you'll notice that it plateaus. And that's because of that parameter, the hot data storage retention time. So basically that means they're storing the data from the sensor up till that retention time. And then they are moving that data over to cold storage. And that's why we can see on the right that for all the sensor types, the data storage is going to increase throughout the duration of the nuclear reactor lifetime. So here you can see the totals of these numbers. And of course, this is on sample data of one of their subsystems where we tried to estimate some numbers for their parameters. But using the sample data, we were able to find they were looking at, even with 50% compression in their hot data storage and 80% compression in their cold data storage, they're looking about data storage on the orders of petabytes and exabytes. And that's just for one subsystem. And so because of this, we recommend that X-Energy further use our tool in the future, inputting real data as they get more and their design matures more. We recommend they use our tool to reconsider their data storage, compression, and offloading practices potentially. Now I'll be passing it over to Nate for an economic analysis.
Thank you very much, Gwen. So in order to estimate the value of our project and the plant support centers to X-Energy, we developed a model to compare X-Energy implementing these plant support centers to centralize their monitoring and diagnostics efforts in comparison to the traditional method where all monitoring is done on site at the actual reactor. So in doing so, we found that implementing these plant support centers, despite having a large initial investment, did increase the net present value significantly, and also saw a 66.7% reduction in labor costs for those analysts. So now I'll pass it off to Andrew to talk about our conclusions and final recommendations.
Awesome. Thank you, Nate. So as I talked about earlier, we provided them with a map to choose their optimal PSC locations. We provided them with recommended counties, but during our presentation, they seem to take issue with one or two of the options. So they're able to change the parameters as they see fit, update the data with the spreadsheet to give them the most accurate real-time information or prediction for them. And they can also use this not only for PSC locations, but also in office space, warehouses, pretty much any corporate site they want to add. And also PSCs, as Nate just mentioned, will reduce the labor costs by 66.7%. And that is with the optimal PSC locations, as well as the staff being centralized in a PSC to serve multiple reactors, as opposed to just people monitoring every reactor very thoroughly. And as Gwen mentioned, X-Energy had no clue, or maybe they didn't have a big clue, but they had no clue how much data they were going to generate. They kind of came to us and like, what are we doing here? How much data are we going to generate? So we gave them a rough estimate of how much data they're going to generate. And this in the future will help them decide what sensors need to be running every millisecond, which sensors they can just do every second, a couple of seconds, just to save the data storage. Because as we saw, petabytes, exabytes, that's a lot more on the hard drive. So they'll be able to, in the future, decide these things way ahead of time, as opposed to get there and then realize that the data is going to cost a lot more.
Awesome. So we just wanted to say thank you to everyone on the CBA team for a great year. They definitely opened a lot of doors for all of us within the cohort. It will mean tremendous value we'll see in our lives. I also wanted to say it was great meeting everyone. We developed some very great relationships between the cohort and across campus. So that's something that we took away as very valuable from the program, because we're going to have these lifelong relationships throughout the cohort. And I know I can go to anyone and ask for anything at any time. So We now want to open the floor to any questions.
So as X-Energy gets new data in like 5-10 years, how will they update that for the Tableau dashboard on the spreadsheet?
Yeah, we have our two different tools. And so for that first tool, that Tableau dashboard for the PSC selection, as Bowen was talking about, we have 5 different data sources there. And so that actually isn't actively updating. It does use the most recent data we could find for those 5 different data sources. But in our report, we do provide instructions on how to keep that data updated, how to pull it and then load it back into the dashboard. As far as the second tool, that is just going to update as their design matures. So engineers will be able to use that, input their information, and that will just be actively updated internally.
Great question. Thank you.
For this order, you mentioned puddles, including redundancy coolers, and also on the script.
So here, the question was, are we accounting for redundancy in our data storage methods, correct? So with our spreadsheet, they're able to input, like I mentioned, data packet size, data storage frequency, and then compression methods for both hot and cold storage. And so they can actually vary those numbers if they'd like to. So they could put, they wanted to have redundancy between hot and cold storage. They want something more readily accessible. It's not as compressed as well as some in cold storage. They can input that into our spreadsheet, but that'll be something the user will input themselves.
Awesome. Thank you guys for your time.